Okay, another rules of limit that we're going to talk about is the power rules of limit. You understand? So, the power rules have many conditions. You understand? These are the conditions that we're going to examine under the power rules of limit. You understand? I put this line so as to know that, as to separate each condition from each other. You understand? I separated the condition from each other. That's why I put this line. Okay, now we have, for the first condition, now we have limit k to the power of n as n tends to infinity. Now, for this condition is that -1 is less than n, -1 is less than n, and n is less than 1. Now, for this kind, the limit of the function is equivalent to 0. I'm going to explain, just pay attention. The limit of this function is equivalent to 0. Now, let's say, don't forget that k is a constant. You understand? K can be 1, it can be 2, it can be 3, it can be 4, it can be 5, 6. Are you getting what I'm trying? It can be 10, it can be 1000. Are you getting what I'm trying to say? Now, for the value of k is a constant now, is a number. For -1 is less than n less than +1. The limit of this kind of function is 0. Now, let's say we have okay, I'm coming. Oh, this should be k. Now, let's say we have 1/3. Pay attention. Let's say we have 1/3. I'm just thinking of what I can do. I'm thinking of a function I can imagine. Okay, 1/3. 1/3 is also a decimal. 1/3 raised to the power of n. Let's say we are asked to evaluate the limit. Please pay attention. Of 1/3 raised to the power of n as n tends to infinity. Now, you know that if you divide 1 divided by 3, you're going to obtain a decimal. You understand? Now, when n tends to infinity, please pay attention. When n tends to infinity, that means n increases in value. You understand? For example, let's say, okay, let's use 1/2. 1/2 is 0.5. Now, if n increases, maybe n is 1 million, you will discover that 0.5 to the power of 1 million, we discover that the value actually approaches 0. You understand? And I told you that the limit of a function refers to the value that we obtain when we take the limit, when we insert the limiting value. You understand what I'm saying? The value that is obtained as output is what we call the limit of that function. Now, if you take the limit of 1/2 to the power of n as n tends to infinity, you're going to have 0, because though we might not actually got 0, but the value tends to 0, so we can say that the limit of this kind of function is 0. So any function that you have, any function that look like this, when n tends to infinity, for the value of k, -1 is less than k. Don't forget that k is a constant and k is less than 1. The limit is equals to 0. Now, for the second condition, where k is equivalent to 1, if k is equivalent to 1 and the value of n tends to infinity, this kind of function will always give us 1. You understand? The limit of this kind of function will always give us 1. Example, let's say you are asked to evaluate limit of k. K is now 1. You understand? For k equals to 1, 1 raised to the power of as n tends to infinity. Now, if you have to evaluate the limit of a function that looks like this, your answer will be what? It will be 1, because 1 to the power of 1 is 1. 1 to the power of 1 million is 1. 1 to the power of 1 billion is 1. 1 to the power of, are you getting what I'm trying to say? So, the limit of a function where k is a constant, I told you, k is a just number. Are you getting it? So, where k is equals to 1, the limit of a function that looks like this will always give us 1. Now, for the third condition, we have the limit of k to the power of n as n tends to infinity. Oh, sorry, I made a mistake. For k is greater than 1. For k is greater than 1. Okay? Now, what will be the limit of a function that looks like this? For k is greater than 1, that means that k may be 2, 3, 4, 5, 6. Are you getting what I'm trying to say? So now, if k is greater than 1 and we limit a function k to the power of n, where n tends to infinity, what will be the answer? The answer will be infinity. The limit of such function will be infinity, and the reason is because when as the n increases, you understand? For example, let's say we have limit of 4 to the power of n as n tends to infinity. Now, because I told you that infinity does not have an actual value. You get what I'm trying to say? Infinity doesn't have an actual value, so we assume a very large value. Let's choose 1 million. Now, if n is 1 million, as we limit n as n tends to 1 million, that means that I'm going to have 4 to the power of 1 million. You are going to discover that the value of this function is going to increase. Is that not it? Now, if n changes to 2 million, you can see that it's going to increase as well. So you can see that this kind of function increases. Are you getting it? So we said that the limit of such function is infinity, because as n increases in value, the function also increases, and this kind of value is the kind of limit is what we call infinite limit. Do you remember? If you didn't remember, reverse the video and listen to the explanation again. This kind of function is infinite limit. This one is finite, this one is also finite. You get what I'm trying to say? So that's it. Okay? Now, let's look at the third condition. Infinity. Now, let's look at the fourth condition. We have limit k to the power of n as n tends to infinity. This one is undefined. You understand? Is undefined. Now I'm going to explain. Just pay attention. This one is undefined. The limit of this kind of function is undefined. Here k is less than or equals to -1. Now if k is less than or equals to -1, let's assume that we are asked to take the limit of a function maybe -2 to the power of as n tends to infinity. This is undefined. I'm going to explain. The reason why it is undefined is because, see, if n, let's assume that n is 2, and you substitute 2 here, you're going to have -2 times 2, right? And -2 times -2, that is what? +4. Now, let's assume that n is 3. You're going to discover that the function is also will increase, right? Yes, it will. But the sign will changes, you understand? So that means that because as n increases in value, the function changes in sign. That means that it is undefined, okay? Because we cannot say that we insert negative infinity or positive infinity. I don't know if you get what I'm showing. Listen to the explanation again. See, when n changes in value, the sign changes simultaneously, okay? And because it happens like that, we are going to call this function the output of this kind of function is undefined. You understand? Because the sign changes repeatedly. Okay? So it changes from positive to negative and from negative to positive depending on the value of n. And because n is infinity, and I told you that infinity doesn't have an actual value, so that means the value of n, the value of this, the output of this function is undefined. Okay, so now I'll give you some questions that I want to attempt, and I want to drop your answer in the comment section. I want to attempt the following question. Now I can erase this. Let's erase this. Now let's say f of n is question 1. Let's say f of n is equals to mh I mean lim f of n limit 0.01 as n tends to the power of n as n tends to infinity. Now we have to take the limit of the function 0.01 as n tends to infinity. What will be the answer? The answer will be 0. You understand? The answer will be 0. Now, I want to ask, does this limit converge or diverge? It converge, you understand? And this kind of limit is what we call finite limit, okay? Now, another example. Take the limit of 1 over 0.1 to the power of n as n tends to infinity. What will be the answer? I mean, for this kind of limit, what will be the answer? The answer will be infinity. And the reason is because 1 over 0.1 is what? On 10, you understand? You're going to have limit of 10 as 10 raised to the power of n. Let me write it. You're going to have limit of 10 to the power of n as n tends to infinity. Now, the answer will be infinity because as the value of n increases, the function also increases. You understand? Now, if the function increases as the value of n increases, that means that this kind of function diverge. You understand? And this kind of function is also called infinite function. Okay? Now, for the third example, let's say we have limit negative 100. Now, this kind is undefined. You understand? It is undefined. Undefined. It is undefined, and this kind of function is undefined and it diverges. You understand? Okay, it's undefined, though it's undefined, it diverges because if the value of n increases, the function also increases. You get what I'm trying to say? So that is it. That is all about limit. We're going to look at, you see, the major categories of limit are finite and infinite limits, but there are also subcategories. You understand what I'm saying? For example, indeterminate limits. Indeterminate limit is a kind of limit that has a numerator and the denominator as an infinite limit. You understand? So you can see. So we're going to talk about more about it in our next class. Okay. So make sure that you don't miss the next class. Okay. And also, before you go, don't forget to hit the like button. Also, subscribe to the channel, share the video to your friend, and drop comments in the comment section. Also, if you missed our previous class on limits, make sure you watch those classes to have an elaborate knowledge on this concept limit, because it's very important as far as differential calculus is concerned. You understand? Okay. So that will be all for this class. See you in the next class.